Hi students, today we are going to learn the topic lateral displacement under the heading refraction in a glass slab. So you can look at this picture PQRS. Here's the rectangular glass slab. Okay, it is having a thickness T. So T is the distance of separation between the two longer sides, parallel sides of the rectangular glass slab. So T is the thickness of the slab. And this is N1 and this is N2. These are the two normals drawn at the two refracting surfaces. AB is a ray of light which is incident at an angle I. So AB is the incident ray which falls on the surface PQ. Above PQ, the medium is air. Below PQ, the medium is glass. So now the light is going to travel from a rarer medium to a denser medium. Is it not? So the light is changing its path. It is not traveling along the same straight line. Instead, it is deviating, it is bending towards the normal. So when a ray of light travels from a rarer medium into a denser medium, it deviates or bends towards the normal. So BC is the refracted ray corresponding to the incident ray AB. So the angle made by BC with the normal is called the angle of refraction, R. Small r is the angle of refraction. So the remaining angle you can see here, this must be I minus R. This small angle is called the deviation of light. By how much angle the light has deviated from its original direction, it is I minus R. It is I minus R. Have you understood? Okay. Next, this ray of light BC, after reaching the surface SR, it has to come from glass into air. So the medium again outside this slab is what? Air itself. So the refraction now is going to take place at the surface SR. This is the second refraction. And this refraction takes place when light travels from a denser medium glass to a rarer medium air along the path CD. So once again what is going to happen? It will not continue the extension of BC. Instead, it will deviate away from the normal. The light will deviate away from the normal. Understand? So this is the angle made by CD with the normal N2. So for the second refraction, you see that the angle of refraction is greater than the angle of incidence. But by geometry, I can say that this angle is also R and this angle also is I. So angle of emergence is also equal to the angle of incidence because the two refracting faces PQ and SR, they are parallel to each other, they are symmetric to each other. Therefore, in this picture, the angle of incidence must be equal to the angle of emergence. Both are one and the same. Okay. Now, we want the definition for lateral displacement. What is meant by lateral displacement? For that, now you look at the incident ray AB, which is extended, okay, which is extended by dotted line. Suppose if the glass slab were not kept on the path of light, suppose if the glass slab was not there, light should have traveled along the direction AB produced, is it not? Because a glass slab is kept on its path, the light has bent along BC and then along CD. Otherwise, light should have traveled along this extended dotted line. Understand? Okay. Now, can you see that the incident ray AB produced by a dotted line is parallel to the emergent ray CD? These two are parallel, is it not? The perpendicular or the shortest distance between these two lines only is called the lateral shift. Lateral displacement. It is also called lateral shift or lateral displacement. Understand that? So, I am going to measure the perpendicular distance between the incident ray produced along AB and the emergent ray passing along CD. Okay, the shortest distance is the perpendicular distance. So, I will find out the perpendicular distance. I will drop a perpendicular. So, this is the perpendicular. This point is taken as E, and this is normal, which makes another perpendicular at the point F. Okay, students. So, this C to E is the perpendicular distance between the emergent ray and the incident ray produced, and it is denoted, CE is denoted by L. So, this perpendicular distance CE is equal to L only is called the lateral displacement, or it is also called as lateral shift. So, how will you define lateral shift? Lateral shift is defined as what? The perpendicular distance. It is defined as the perpendicular distance. Okay, distance between who and who? Perpendicular distance between the emergent ray. Understand? Between the emergent ray and whom? And the incident ray produced, and the incident ray which is extended. Incident ray extended or produced. So, this is the definition for lateral displacement or lateral shift. It is a perpendicular distance between the emergent ray and the incident ray which is extended. So, in this picture, CE is the perpendicular distance. Okay. Now it is very easy for us to derive an expression. Now you should concentrate on two right-angled triangles. You look at the diagram and tell me which are the two right-angled triangles visible inside the glass slab. Can you see this B, E, C or B, C, E? Anyway, okay, triangle B, C, E. It is right-angled at which point? At E. Similarly, you can see that B, C, F. Understand? And B, C, F is right angle at F. So I will take first one right angled triangle. In the right angled triangle BEC, that is BEC. So this is right angled at E. Understand? This angle made at B is I minus R. So, what is in this triangle? What is the value of sine of I minus R? Sine theta is equal to what? Opposite side by hypotenuse. Which is the hypotenuse for this triangle? You see, opposite to 90 degree, the side BC is the hypotenuse. And which is the side opposite to this angle of deviation I minus R? That is L, CE. So, this is now equal to the side CE divided by the side BC. Understand that? Or sine I minus R. Okay, sine I minus R is equal to, instead of CE, I will substitute L. That is a lateral shift. Understand? L is the lateral shift. CE is equal to L divided by BC. Or once again, I will take BC to the left hand side. So what is BC is now equal to L divided by sine of I minus R. So this is a very important step. This is equation 1 for us. Have you understood this first? So I have taken the right angled triangle BEC and found the value of sine I minus R, which is the other right angled triangle. Instead of BEC, now BFC, which is also right angled. So in the right angled triangle BFC, what is the value of a cos of this angle R? BFC, okay, you can see here, cos of this angle R, I will find out cos R. So cos theta is equal to what? Adjacent side by hypotenuse. Which side is adjacent to R? Adjacent to R, it is BF, is it not? So this is BF divided by hypotenuse is the same BC for this triangle also. So by BC. Or cos of R is equal to this B to F distance also is equal to PS, which is also equal to QR, that is equal to the thickness of the glass slab. So instead of BF, what I can substitute here in the numerator is thickness T. So this is thickness T divided by BC. Once again you take BC to the left hand side. So I can write this T or BC is now equal to T divided by cos R. This is another very important step in this derivation. So this is equation 2. Can you see that equation 1 and 2 have the same left hand side BC? Is it not that? So I am going to equate 1 and 2. I am going to equate 1 and 2. So comparing equations 1 and 2, comparing equations 1 and 2, L by sin I minus R. So I will take a L, okay, L divided by sin I minus R is equal to T divided by cos of R. We need an expression for L only, is it not? Retain L on the left hand side. All other terms is shifted to the right hand side. So RL is now equal to T into sin of I minus R divided by cos of R. So this is the expression for the lateral displacement or lateral shift. How much easy derivation you see? It's a 5-mark question. Okay, or 3. Whether it is 3 or 5, answer is the same. Suppose if it is a 5-mark question, means we have to extend this. Some factors on which lateral shift depends. Can you all see that L is directly proportional to T? Is it not? So the lateral shift, okay, increases. Lateral shift increases when thickness if thickness T increases, because they are directly proportional to each other. When the thickness is large, then the lateral shift also will be large. Similarly, this lateral shift also increases. Lateral shift also increases if angle of incidence increases. If angle of incidence increases, also lateral shift will increase. So for the NEET and JEE and all other competitive exams, definitely one question will come from this. Understand? So how they will ask the question? The lateral shift dependence on the lateral shift on the thickness for the same angle of incidence. Or when the thickness of the glass slab is doubled and angle of incidence is also doubled, what will be its impact on the lateral shift? Like that only they will ask the question. It is very, very easy. I hope you must have understood this. Fine.